Sure, I will give that.
Or sometimes even more dangerous the other hijack. And since this is a logical vulnerability, this persists across code refactorization, and also it's highly valuable to exploit because you don't need to care about memory allocation, buffer overflow. So it's most likely you're going to be able to exploit it regardless of memory protections. And these vulnerabilities can be found in both like Microsoft products and third-party products. No worries. So the typical example of this scenario is an antivirus. The damn antivirus, right? It's ironic. Why a program that is supposed to protect us is the one that introduces vulnerabilities? But let's keep this example in mind the whole presentation so we can follow along better. So let's keep this scenario, right? So we are a low privilege user running an antivirus. So the antivirus needs to have the highest privilege on the system, or not the highest, but needs to have high privilege on the system in order to delete files or quarantine them, regardless if they are in a protected folder or in a public folder. So you, as a malicious user, use this time of check, time of use typical bugs that is persistent in across different antiviruses. So you first place a well-known malware, and you tell the antivirus to analyze it. And while it is analyzing it, you create a way to replace the path, either by a symlink or some way to change the path, and then you point to a critical binary. So when it decides that the antivirus decides that the malware needs to be deleted, you're actually pointing to a critical binary, and you cause a denial of service. So this is the typical scenario that you're gonna find when you check for this type of bugs on the internet, but actually it's not only for deleting files, it could be also for leaking information, uh, or creating binaries where they shouldn't, so you can also execute code. So the landscape, as you can see, as I mentioned, many antiviruses have reported this issue within the past years. So here on the right side, you can see that many antiviruses have had this problem before. And on this image, you can see that it's not only an issue that antiviruses have. Like many other type of services can also be running with high privileges and accessing low privilege folders. So what I want you to take from this presentation is have a hunting strategy. I would say this is the most important thing that I want you to take. So imagine if you are a developer for a company and you see that there's a persistent bug across different services or programs, try to find that. What is the common issue that you find across your products or services? And if you're a researcher, try to find something that is common among different services or products that you're trying to test. So this is a typical scenario, right? Everyone's gonna tell you that this isn't failure, but not trying is. But I actually think that this is what actually is failure, right? When you're, as a researcher, spend a lot of time getting a product, reverse engineering, trying to find for a specific vulnerability, and then you go there and you never find it because that specific product doesn't have that vulnerability that you were looking for. So the strategy that I propose is try to catch as many as possible for that same vulnerability that you have in a single device. So typically in a vulnerability research, you follow this process, or at least that's the way I do it, is first you do the hunting, right? So it's like narrowing down all your chances in a system for the bug that you're trying to catch. Then you validate. You validate if the bug is actually a bug, if it's something that could help you to find what you're trying to look for. Then you exploit it. Here it depends what it's it for. For example, if you send a report to a big company like Google or Microsoft, most likely they're going to ask you for an exploitation scenario, right? So you can see a POC. And then the post-exploitation scenario, I would say it depends, maybe fun and profit, but also I found that many like developer teams, if you don't give them like a real scenario in which attackers can take advantage of this, they don't prioritize fixing the issue. So why I'm proposing the instrumentation. First, I'm going to explain the other types of testings that you could try. So first, static testing. So previously, someone talked about SendRep here, and I would say SendRep is great. I've used it most of the time. But when you're trying to do the hunting part, I think this is not the best scenario, because for this type of bugs, what you need is context. Many like code scanners don't even gonna look for this, because it's very hard to understand what's the integrity level of the process that is running and what are the actuals of the folder in which the user can access to. So it's very hard to automate those static analysis. So maybe the only thing that can help you is shifting left, right? Like thinking of how to solve it since you are designing your product. But what about dynamic manual testing? So yeah, if you search on internet, maybe you're gonna find that the typical scenario, right? You open the service that you're trying to catch the vulnerability for, and you open process monitor and try to see and filter if at some point the program access non-privileged folders. And that's the typical scenario. But what happens if the process that you are, the vulnerable process happens just after the boot process, and then while you open Procmon, you already lost that process, right? And yeah, I know you can maybe tell, I can boot up a script that I can yeah, create a script for Procmon that starts monitoring since it boots, but I would say that it adds a lot of overhead to these type of things when you have easier things to do here. And then, of course, debugger and other process explorer tools are great for the validation and the exploitation side. But for hunting, I would say they are very slow and not as effective as instrumentation would. So instrumentation might save you here. So has anyone used instrumentation before? So well, dynamic instrumentation is basically injecting code into a program that is already running, and you don't need to recompile it, you don't need to modify the code, so you don't need source code. That's why this is very useful, right? What if it's a source code program? You don't have the source code, you can still do it. You don't have to recompile it, you don't have to do any changes. And there it has many uses. So debugging and reversing, software analysis, performance analysis, security testing, but for us, it's hacking. And this is how it looks when a program calls a function without being instrumented. So the source function calls a collect function, and after it ends, it returns to the source function who called that function. But when you intercept it, what you are actually is detouring the function. And it is done by a trampoline function, which first here you can create your own function to do whatever you want. So for example, you can create your own printf to do modifications to the original printf that exists on the program. And then it goes to some, you need to keep some alineation with the program and the parameters. And then after it goes, you can direct it to the target function, which is the actual function. In this example, the actual printf, and then it goes again to the Detours function, and then to the source function. So here you can either modify the input that goes to the target function or the output that you receive from the target function before sending it back to the source function. So that's the cool part. And if you Google instrumentation frameworks, you're gonna find the most common one, Frida. And I love it. Back off. Don't go for me. I love Frida. It's nothing bad with Frida. I actually have this blog in which I put this famous dream chess playing against stockfish. You know, if any of you play chess, you know that stockfish is very used in the chess community. So these are two, basically a chess engine and a chess video game playing against each other. But so Frida is really cool. You can use it for instrumenting Android, macOS, iOS, whatever. But something that I think is very, very useful, or something to keep in mind, is try to always feel this philosophy of native first development or minimalist software development, which means that always try to use platforms that are already on your system, or something that you don't need to do a lot of things to make it run. So of course, you can say it's pretty easy to set up, but let's think about if your company wants to test this in 1,000 testing machines, you would need to install all the dependencies that you need on Frida, and of course you can automate it. But as I said, I always try to do the minimal changes as possible. And so for that, I'm gonna introduce you to Microsoft Detours. Microsoft Detours is open source, is maintained by Microsoft. It works well. It says only up to Windows 10, but I have run it on Windows 11. I think it works well. I haven't found any bugs yet. So, and another reason is because I haven't seen too much advertising on Microsoft Detours, to be honest. The first time I tried to read about it was on Guided Hacking. I don't know if you ever heard of this platform, but it's pretty cool to start learning reverse engineering and a lot of stuff. These guys specialize on gaming hacking, so all the perspective that they take to learn you, to show you or to teach you how to reverse engineer something is through video games. So it's really cool. And that's the only actual blog that I've seen that has to teach me how to use it. So I wanna give a more advertising to Microsoft. Even though I don't work at Microsoft anymore, but it's still a really cool platform. And then let's try to everything that we find through Microsoft Detours. I will use ETW to log the events that I find. So why ETW? Because as I said, it's already in your machine. So any Windows machine already works with ETW. All the events that happen in the operating system are and that are logged are through ETW. So you don't need to install anything else. And that's why. And also creating your own logger, it's pretty demanding, a lot of time consuming, and you can have several issues with that. The cool part about ETW is that you can specify when to write into a file, and in the meanwhile, it's going to write into a buffer. So that's going to make the reading and writing faster. So and it's like this process of recycling the buffer. So events provided are write into the buffer, and then after this, some condition, either the size of the buffer, the minimum byte number, the maximum byte number, or a certain flush time. For example, I'm gonna run this tool in my machines for 7 days, and if this hasn't flushed, I'm gonna force it to flush into a file. So every 7 days or every week, you can get an ETL file and analyze it. So that's why it's pretty cool to rely on it. Okay, so now we have the tool, we have the idea of what we're gonna do, but what should I instrument it? So in my case, or the scenario we're trying to explain at the beginning, which is dealing with file operations, I first went for the most common operation files. Like if you go and open your program, you're gonna see that if you search for file, just the word file and filter that out, you're gonna see a lot of create file. That's the most common one that you're gonna get to see. And the reason is because through create file, if you look at the documentation, you can see that create file can help you not only to create file, but also to open files and rewrite files as well. So that's why it's very used, this function. So now, the second hint or the second tip that I want to give you is go always for the inner function. So what does that mean? Maybe you're gonna tell me, oh, this is a Windows API. No programmer is gonna remove the symbols. Yeah, I got you. But I wanted to give it as a general as possible. So there's gonna be cases in which the programmer removes the symbols, and then you don't get the symbols, and now you cannot instrument something if you don't have the name of the function. So if you look for the inner part, maybe you're gonna get something interesting. For example, in this case, you're gonna see, believe me, you can go and reverse engineer all the libraries of kernel-based DLL, NTDLL, and all the operations related to file operations always work like this. There is the Windows API, which is a wrapper to the same kind of thing, but internally, in which they deal with the flags and everything you pass to. And then it's another wrapper for the actual system call. In this case, empty create file, right? That's the one doing the heavy lifting. So that's why you need to go to the deeper one, because you're gonna realize as well that many of the operations actually end up relying on empty create file as well. So yeah, you can create many functions to instrument all as many functions as you want, but it will be easier if you just instrument empty create file. You just analyze the flags that are being passed to it, and yeah, and also because as syscall, most of the cases they're never gonna remove the symbols because it's a syscall, right? It needs the information to pass it to the kernel. So yeah, you can go and check the documentation for the syscall that you're trying to instrument, in this case for empty create file. So I started creating the actual tool that is going to help us to find this kind of bugs. So first define the function pointer of the function that we're trying to instrument. So we see I just literally copy paste that, and then now first we create it as null because we need to search for it afterwards. So Detours is gonna give you, I'm gonna give you some examples of Detours, but Detours has something really cool that has Detour find function. You just specify the library and the function you're looking for, and then you already have the function pointer where it should be. Then, as we mentioned at the beginning, we need to have, we're looking for any like any higher privilege that is any higher privilege process that is accessing one of these ACLs, right? This is just a limited list, just not to make a bigger image, and anyone can see it. But this is not exclusively the only ones that I'm looking for. It's going to depend on your scenario. But here are some of the low privilege groups that you find on a Windows machine. And these are blocks that are defined as strings, and I just comment what does it mean each of us. So yeah, what I'm looking for in my program, well, first, here this slide just tells you like what are the essential parts of a DLL when using Detours, and also because the documentation tells you that the easiest way is to create a DLL and then inject it into a program. And I'm going to explain why this is going to help us a lot. But first, let's look at the code. So I don't want to confuse you with so many code. This is just the DLL main. And as I said, this is the actual integrate file that we found through Detours find function. Once you have where is it, you need to, as this works as a transaction. So here where the transaction begins, and here we got the list of IDs that we defined. We run this update thread, and the update thread, what it's gonna do is gonna update the memory addresses. So when you do the attach part, you're gonna be able to find the current address and the current function that you're targeting. So here, for example, here it's saying that the essential part is that you attach to the, once it attached, you need to give them the function that you created, modify it, the modified function you created, and then the actual function that you are looking for. So that's what I'm doing here, right? Just the actual integrate file that I defined there, that is already found by Detours, and then another modified function. And here is the modified version. And what it does is just, as I said, look for the integrity level. So it means if it's medium or higher than medium, then I care about that process. If not, I just return to the actual integrate file the same parameters without any modification, right? But if you want to modify it, you can pass a different parameter to the actual file. In this case, I just want to check what's the integrity level, and then if it's if that process is higher than medium, and the list of, or the ACLs of the folder that is being accessed to is one of my list of interests that I previously defined that I just showed you, then I'm gonna use ETW to log it into my events. And that at the end is gonna give you a database of all the, or like a that looks like a database that is, it contains all the events that found that has this condition that a high level privilege process access a low privilege folder or file. And then you can use this. This is a really cool feature that Windows system has that not much people know about it, but it's called the AppInit DLL. And what it does is a registry key that when you change this value to 1, the load AppInit DLL, and you define a path to a DLL in this and AppInit DLL, it is going to inject this DLL into every process in the system after boot. But the only caveat for this is that it depends on the policies of your company, because in order to make this work, you need to turn off the secure boot option in your BIOS. So that's gonna be like, depending on the policy of your company, maybe you're not gonna be able to do so. But if it's a testing machine, most likely this is not a problem, right?